Support vector machines ML algorithm. Support vector machines. SVM. In machine learning. AI intermediate level. Introduction. Machine learning models are used to find patterns in data and make predictions. One powerful algorithm used for classification and regression problems is the support vector machine. SVM. Support vector machines are widely used in machine learning because they can create highly accurate decision boundaries between different classes. SVM is commonly used in applications such as image classification, text categorization, spam detection, handwriting recognition, bioinformatics analysis. Understanding SVM helps learners understand how machine learning models separate complex data patterns. What is a support vector machine? A support vector machine, SVM, is a supervised machine learning algorithm used for classification and regression tasks. It works by finding the best boundary, called a hyperplane, that separates different classes in a dataset. In simple words, SVM equals an algorithm that finds the best line or boundary to separate data into classes. Example concept. Data points means separating, boundary means classification. The goal is to maximize the distance between classes and the separating boundary. The idea of a hyperplane. In SVM, the decision boundary used to separate classes is called a hyperplane. For example, in 2D data, the hyperplane is a line. In 3D data, the hyperplane is a plane. Example concept. Data points means hyperplane means class separation. The hyperplane divides the dataset into different categories. Maximum margin concept. SVM tries to find the hyperplane that maximizes the margin between two classes. The margin is the distance between the hyperplane and the nearest data points from each class. Example concept. Wider margin means better class separation. A larger margin helps the model generalize better to new data. Support vectors. The data points closest to the hyperplane are called support vectors. These points are critical because they determine the position of the hyperplane. Example concept. Closest points to boundary means support vectors. If these points move, the decision boundary changes. Linear SVM. When data can be separated using a straight line, we use linear SVM. Example dataset. Feature 1, Feature 2 class. 2 3a, 3 4a, 7 8b, 8 9b. Example concept. Linearly separable data means linear hyperplane. Linear SVM works well when classes are clearly separable. Nonlinear SVM. In many real-world datasets, data cannot be separated with a straight line. Example concept. Complex data means nonlinear boundary. SVM solves this problem using a technique called the kernel trick. Kernel trick. The kernel trick transforms data into a higher dimensional space where it becomes easier to separate. Example concept. Original space means higher dimension means separable data. Common kernel types include linear kernel, polynomial kernel, radial basis function, RBF, kernel, sigmoid kernel. These kernels allow SVM to handle complex patterns. SVM for regression. SVM can also be used for regression problems. This version is called support vector regression, SVR. Example applications include stock price prediction, sales forecasting, demand prediction. Example concept. Input features means SVR means numeric prediction. Instead of separating classes, SVR predicts numerical values. Advantages of SVM. Support vector machines have several advantages. Advantages include effective in high-dimensional spaces, works well with smaller datasets, robust to overfitting in many cases, flexible with different kernel functions. Example concept. Margin maximization means better generalization. These properties make SVM powerful for many ML tasks. Limitations of SVM. Despite its advantages, SVM has some limitations. Limitations include slower training on very large datasets, sensitive to choice of kernel and parameters, harder to interpret compared to simpler models. Example concept: large dataset means slower SVM training. Because of this, SVM is sometimes replaced by faster algorithms for very large datasets. Example Python code. Example SVM model using scikit-learn. Import the algorithm. From sklearn.svm import svc. Train the model. Model equals svc. Model.fit. x_train. y_train. Make predictions. Predictions equals model. Predict. x_test. These commands train and test an SVM classification model. Real-world applications. SVM is used in many real-world AI systems. Text classification. Classifying emails into spam or non-spam. Image recognition. Detecting objects in images. Bioinformatics. Analyzing genetic data. Face detection. Identifying faces in photographs. Financial prediction. Detecting fraudulent transactions. Concepts learned from SVM. Understanding support vector machines helps learners understand. Checkmark how machine learning models separate classes. Checkmark how decision boundaries work. Checkmark how kernels enable complex classification. Checkmark how margin maximization improves performance. Checkmark how SVM handles high-dimensional data. SVM is one of the most important algorithms in intermediate machine learning. Simple definition. Support vector machine. SVM. A supervised machine learning algorithm that finds the best boundary. Hyperplane. To separate data into different classes. Final summary. Support vector machines are powerful machine learning algorithms used for classification and regression tasks. They work by finding a hyperplane that separates data while maximizing the margin between classes. Support vectors are the data points closest to the decision boundary and play a key role in defining the model. Using kernel functions, SVM can handle both linear and nonlinear datasets. Because of their accuracy and flexibility, SVM models are widely used in machine learning applications such as image recognition, text classification, and fraud detection. Understanding SVM is an important step in mastering intermediate machine learning algorithms.